Thank you for joining our webinar today. What's so hard about conversational analytics? My name is Justin Fry. I'm hoping to run the webinar today along with David Atwater, Senior Scientist at TalkMap, who's our speaker today. Some housekeeping issues. Questions, we'll have a Q&A session at the end of the webinar. You can ask questions at any time using the Q&A button in the middle of the Zoom interface. Now over to David Atwater, Senior Scientist with TalkMap.
Okay, thank you, Justin. Hello to you all. Thank you for joining this webinar today. This is the second in a series of webinars. Those of you who joined the previous one, and I hope it was many of you, we looked at Gen AI and large language models, and we just looked at what they are and some technical details of how they work. Today, we're going to look at the topic of how hard is conversational analytics, with the sort of subtitle of why doesn't word spotting work and how can large language models help us move forward in the field of conversational analytics. There will be some later seminars in the series looking at the impact of large language models on chatbots. Then we're going to look at summaries, and then finally we're going to draw up and look at some of the risks and opportunities in general on Gen AI. So the topics for today, for those of you who missed the previous seminar, I'm going to do a very quick recap on large language models, but I do encourage you to go and watch the previous webinar if you can. Then we're going to talk about conversation in general, what's special about conversation, and then particularly what's special about conversations in the context of contact centers. And then finally, we're going to look at, why is conversational analytics hard? Why is the current approach of just trying to spot words just not working? And how can large language models help with this issue? So let's, first of all, just quickly recap on the previous session. In the previous session, we just looked at what is generative AI and what is a large language model. And put simply, a large language model, based on something that's put into it, will try and predict what's coming next. So we have cool as a cucumber. Mary had a little lamb whose fleece was white as snow, for example. And we talked about how this simple underlying technology, when it's coupled with deep learning, which is essentially networks of artificial brain cells that are put into particular structures and taught with large volumes of data, how when we couple these technologies together, we're able to create this thing that we call a large language model that's able to take some kind of input and generate a prediction of what might be coming next. And in its simplest form, that might just be predicting the next word, as you can see on the screen here, a lamb whose fleece was white as snow, etc. And as it cycles around, it can generate words, and that's why it becomes generative AI. But in the previous session, we looked at how it's gone way beyond that to the ability to actually perform tasks. And so here's an example from the previous seminar where we fed an online large language model simple transcription of a conversation and asked the question, why did the customer contact customer service? And you can see here that the large language model summarized the conversation. They were trying to get their home phone hooked up, and they've been unsuccessful, etc. And then we asked the question, the large language model have been around a long time. What makes them special now? And the answer really is they're just huge. They're trained on an enormous volume of data taken from articles, papers, chat, conversations, etc., taken from the public domain. They take huge input context now, so we're able to feed entire conversations in and ask questions of them because they can take several thousand tokens, and by tokens we mean words. And then finally, the models themselves have become huge with billions and billions of learned and tunable parameters, which makes them so general purpose and able to perform some of the tasks. We then just wrapped up with some words of caution. First of all, large language models aren't the savior of the world. They're highly plausible, but not always correct. So they do make stuff up. They do carry unique risks, and they don't stand alone. You can't kind of just take a large language model and be able to do conversational analytics without needing extra capabilities and infrastructure around it. And this talk should highlight some of that stuff. So that's just a very quick summary of the previous seminar. If you're interested in that detail, go back and actually watch the seminar. Let's get on to today's topic, which is what's so special about conversation. Well, first of all, it's worth noting that we all do conversation so naturally that we're often not aware of what it actually takes and how conversation really works. So we're going to take a little bit of time to actually explore that. One of the key features of conversation is we take turns. So you'll see in the example on the screen here, we have a simple It's a customer care conversation, but it could be any kind of conversation. And you'll see we have an agent speaks, then the customer, then the agent, then the customer, and then the agent says a few things, then the customer. So you see they're taking turns. It goes agent, customer, agent, customer, agent, customer. And this is part of the normal cut and thrust of conversation. And you'll see that each step builds on the previous step. Each turn builds on the previous turn. So we have a greeting from the agent here, and then the agent asks who they're speaking with today. And then you'll see that the customer, essentially, they take a turn to answer that particular question. Then they're asked another question, how are you today? And they feel able, they have their turn, they can take their turn and answer it. And then the agent continues to respond. You'll see here the agent currently is taking initiative. Why is that there? And then you'll see that there's some breakdown in communication here, presumably a time delay, and the agent asks the question, are you still there? And then something interesting happens here. The turn sequences get a little bit broken up. The customer actually is responding to this question here. Why is that? We tried several times to get our home phone hooked up and still no phone information. And then you'll see at some point, there's probably overlapping speech here. We'll come into this in the next slide. You'll see that at some point, the customer is actually responding to this second question here. Are you still there? And they explain, yes, they are, but they're 73 years old. And then finally, the agent takes a turn and wraps everything up, wraps the conversation up. So we take turns, but as I've already alluded to, we also, with spoken conversation, we speak over each other. So it's not as simple as he said, she said, he said, she said. There's a lot more going on because, in fact, both people or multiple people in the conversation can speak at once. So here's a real example I've taken from a real conversation. We've got a speaker here who's saying it's failed, and I was wondering why. And you'll notice here that there's an apparent interruption with a This is what we call a back channel. It's not an actual genuine interruption. It's the other person just indicating that they've heard. But in a customer contact transcription system, this can often end up breaking up these two sentences, even though they don't need breaking up. Then if we move along a little bit further in this conversation here, you'll see that this speaker here says, I was wondering why. And you'll see the second speaker here now, because there's been a pause, they try and take a turn. So they try and start speaking here. I see, so just. But what actually happens is this speaker is also continuing on. So we get what's called a competitive interruption. And what happens is this particular speaker here does what's called a back off. They actually stop speaking and let the other person speak. So the other person says, I've been getting a lot, maybe. And then there's another turn break here, another opportunity to take a turn, in which case you'll see this I see, so just is represented. I see, so just to be sure. So this is typical of normal spoken conversation. We'll have two speakers, they speak over each other, but it becomes very, very important when you're looking at transcripts of spoken conversations, particularly from spoken speech to text systems, because you can often see this language all getting jumbled in together. So one of the things that we take a lot of care with in our product is to make sure we can reconstruct some of these phrases to make sure we can get the meaning. So we speak in turns, we speak over each other. We're also highly disfluent. So if we look at this conversation here, how can I help you today? I just went, So the customer starts to speak, I just went. And then you see they do what's called a replan. I just wanted to remove a line. So this is called a referendum. They stop and essentially they repair what they were saying and they speak again. And this is one type of disfluency. There are other types of disfluency we see in language. We see these ers, which are either what we call floor holding, so they're a noise just to make sure that the other person doesn't speak, or they're a noise to say, I'm thinking, because I'm still building my sentence. And it can be up to 7% of words in a conversation can actually contain disfluent speaking. And then we see another major disfluency here. We say, are there any other questions or concerns? And they say, no, that's it. But then notice suddenly the no becomes a yeah, as there's a replan, as presumably they're trying to juggle the mind of the user between a positive yes and a no. And they essentially flip the sense of what they're saying. And they say, yeah, I mean, yeah, I don't need it anymore. So you'll see there's a huge amount in spoken conversation that's going on to manage the channel, to do with managing thinking, to do with managing floor taking and turn taking, as well as the actual content of the information. So that's kind of another special feature of language. Next, we build models in our heads. Conversation is incredibly efficient. And the way we make it efficient is because each of the people who are speaking build a picture of what they think is going on in the mind of the other speaker. And then what they say essentially tries to nudge along that understanding. So underpinning conversation is what we call the common ground. Both speakers in this conversation will have a common understanding of English. They should have a common understanding of the meaning of most words. And they may well think they have a common understanding, for example, of the topic that they're talking about. But what will then emerge in the conversation is to what extent this common ground is common. And then they'll start trying to shift each other's thinking. So it starts out like this. Each speaker in a conversation essentially has their own thoughts and desires of where they're trying to go. So they have, I'm thinking this, or I want this, or I want to achieve this. And the other speaker is also, and this is internalized, it's not external. They also have their own thoughts and desires. But on top of that, in a conversation, we build a model in our heads of what the other person is thinking. So the speaker on the left is thinking, I think that he now thinks or wants. And then the person on the right is thinking, I now think that she now thinks or wants. And this can go up many levels. It can go up nearly 7 levels up. I think that he thinks that I think that he thinks that I think, etc. And we just do this naturally. We build these models in our heads of what we think and what also we think the other person is speaking. And then conversation basically is the process of building on this common ground and using words to influence what the other person thinks and also what the other person thinks that we think. So we cooperate to achieve a goal, and there are certain principles that we tend to follow. These were identified by Grice way back in 1975. The general principles of a good conversation are that we'll try and be as informative as possible, which also means being as terse as possible, be relevant, be clear, and be honest. So each step that we take is a cooperative step towards trying to align those internal models that we have of thinking. So let's just quickly look at this example here. We've got, thank you for calling Acme. This is basically an informative statement to let them know that your person you're speaking to is an agent of Acme. Then there's a little bit of social interaction, which we'll perhaps come on to later. And then you'll notice here, the customer spontaneously says, I've already given my details. And what they're trying to do is move the conversation forward by being maximally informative, because they understand that one of the important things they're going to need to do is be verified before they can move on. And then the agent essentially establishes this as common ground by acknowledging that they're verified. So now this is moved into their common ground. They both understand that they're verified, and they can move forward to addressing the next step. You notice the agent asks a nice open question here, which essentially hands the power over to the customer. And then they start being highly informative and efficient as they try and communicate their problem. But they're building on a common ground. They're making an assumption that the agent understands what upgrade means. They're making an assumption the agent understands what an iPhone 12 is, what an email is. And then very importantly here, the customer states that they got an email saying that the phone was not fully functional or in good condition. They don't mention that they returned a phone back to the organization. But there's an assumption in there. So you'll see that part of the process of conversation is we're incredibly efficient with what we present, with the assumption that the common ground, the other person will interpret it. And in fact, this is what happens. The agent clarifies their understanding that this must be in the context of a returned traded in phone. And you'll notice that's enough. It's not mentioned again. They've now very, very clearly understood that this email is associated with a trade-in. So the customer can just keep forward, giving more information. And then they say, look, they checked the phone. Well, who are they? It's not mentioned in the conversation. But the agent again signals their common understanding of this by saying, I tell people all the time to go to the store. So you'll notice the agent here is establishing the common ground now that they must mean the store. So they're aligning their understanding of the problem here. There's an awful lot extra going on here. By saying I tell people to go to the store to do a verification, they're indicating that they believe the customer had it verified at the store. And you can see that that moves on to the agent actually then accepting the customer's problem and accepting to get it cleared up. So you can see there's an awful lot going on in the conversation. There's this common ground. Then there's the building models in the heads of what the other person's saying, giving them minimal but most useful information to move it forwards, which means that not everything that's important to the conversation will actually surface in the conversation if the two people in the conversation understand what they're talking about. So let's just go and explore now what's particularly special about contact center conversation? Well, the most important thing that distinguishes contact center conversation from normal conversations is what we call the asymmetry of roles. So normally a contact in a customer service environment will be initiated by the customer and the agent will be responding. So there's an immediate asymmetry of roles there in that one person has chosen to contact the other. The next thing is that the customer has a lived experience of the problem that they're experiencing right now, but they probably don't have a good mental model of how the products work or how the companies work. Whereas the agent has a very clear mental model of the policies and procedures of how the product work, but their job is to understand the customer's immediate lived experience. So again, we've got an asymmetry of knowledge as we move into this conversation, and the conversation will help to tidy that up. The next thing is that there's different social power dynamics between the two speakers in a customer service conversation. The customer has high social power because it's generally accepted that a customer shouldn't be contradicted or shouldn't be argued with or shouldn't be put down. So customers often understand they have a lot of social power to try and move things forward by the force of the fact that they are a paying customer. But the agent actually has all of the procedural power. They're the ones who can decide what happens, what does or doesn't happen next, and give explanations as to how that might unfold. And we'll see later as we look at some conversations how this plays out in real customer service conversations. So this leads to a social contract, which is not symmetrical. The customer's social contract is that they generally will expected to trust the agent's knowledge and trust that the agents will move things forward. And then the agent's social contract is essentially the agent is expected to adopt the customer's goal and to the extent that that's possible. So this asymmetry leads to some interesting structure within conversations. Often conversations have a very similar structure as they move forward, and it's due to this asymmetry. So let's look at this example here. We start off with a customer goal or problem specification. There's some social stuff going on here. Thank you for contacting customer care and how are you today? And that's the agent essentially starting to establish the social contract with the customer. But the customer then has the initial lived experience that needs to be communicated. So the conversations nearly always start out with a customer explaining their lived experience understanding of what's wrong at the moment, but their understanding may not be correct. And notice very quickly the initiative shifts to the agent. So now the agent's asking, what's the color of the light on the modem? What's the weather like? Have you got multiple devices? Have you rebooted your device recently? This is what we call the diagnosis or the troublemaking phase. And what's actually happening is the agent is taking the customer's expressed experience or problem and is asking probing questions to convert that into a diagnosis of how that relates to their understanding of procedure and policy related to the products that they offer. And that leads to, ideally, the offering of a solution. So then in an ideal conversation, we then lead to a solution phase where the agent will offer a solution. And then you'll notice the social contract here. The customer starts asking, what is the service appointment going to achieve? Which is kind of a question about, I don't know whether I'm going to trust this. But notice they almost immediately flip into, do you know what? I recognize that they've got the procedural power and I need to just trust them. So you can see the social contract working out here. That's fine. Go ahead and schedule that. The agent deals with this concern and answers it, and they're back online, and we've got a nice outcome for this conversation. But of course, conversations don't always work out as well. Sometimes a mismatch in the common ground or the understanding of how products work or expectations can lead to failure within customer service conversations. So here we have a customer who's saying, my Wi-Fi says I've reached my data limit here. How's that possible when I pay for unlimited? So the common ground in terms of the customer's understanding of the word unlimited is it's unlimited. Whereas in fact the agent then, so here's our expression of the lived experience. Now the agent has to tie this into sort of procedural knowledge. And what they explain is that you can have as much internet as you want, so it is unlimited, but once you cross a certain threshold, your speeds slow down. So they're essentially expressing a mapping between their understanding of how the products work to the common ground understanding. They're essentially trying to shift the customer's understanding of what the word unlimited might mean. But the customer's not playing. And so the customer essentially starts pushing back on those cooperative principles now in the dialogue, and they start challenging this definition of, so unlimited does not mean unlimited. And we've got some sort of a measure of passive aggressiveness here, showing that, you know, the social contract is starting to break down. The customer is not feeling that their goal is being adopted or that their worldview is being listened to. But the agent has the procedural power, but they don't have much social power. So they end up having to essentially just repeat the same thing again and just explain this discrepancy. And who knows where this conversation goes next? The customer will either accept that they need to bow to the agent's knowledge and the structures that they're working in, or the customer will use their social power to escalate, and we end up in a complaint situation. So those are some of the characteristics that are unique to customer and agent conversations in particular. Now let's look at conversational analytics and the technologies we would use to actually analyze these conversations. So the subtext for this section is really why word spotting doesn't work and how large language models can help. So let's just run through some of the key things that you'll want out of your analytics system. One of the most important and sometimes often overlooked is that we need to be able to count things at scale and in volume, which means we essentially need to be able to categorize things. Up to now, we've been talking about individual conversations and analyzing individual conversations, but a contact center will take millions of contacts, and knowing what goes on in a single conversation is generally not useful. You need to be able to count things in the hundreds and the thousands so that any changes you might make will have measurable and identifiable benefits. So questions like, why did the customer contact us? Was there a positive outcome? Did this get resolved? It's not good enough to have an individual answer for each conversation. You need categories. And so, for example, a nice simple example, we take this from our current product. Our current product uses large language models and language technology to actually discover the underlying contact reasons that people have for calling the enterprise, and then it counts them. It does this completely automatically with no human intervention. And so this is an application of large language model technology. But this can be done with word spotting. It's just an awful lot harder. You see here now that things are countable. So now we can talk about, 2.2% of conversations are about people who call with problems with the internet, for example, or here, slow internet. 1.2%. Now let's just think about this word spotting versus large language model or technology constraints here. Here's a range of sentences that our current product will group together under the category slow internet. And you'll notice initially it's looking promising that word spotting could get us a long way. So if we look for sentences that have got the word slow and internet in them, we might get ourselves quite a long way to be able to try to use simple word spotting to do some of this counting. But it runs out of steam pretty quickly. So for example, here we've got the word internet. We've got no mention of the word slow. Instead, we've got the word buffering here and not working. The large language model is clever enough to realize that if something's buffering, it is still to some extent working, and therefore it's categorized it as slow. Well, a word spotting technology wouldn't be able to do that, and you may well categorize this wrongly. Notice here we've got internet running at 0.25. An implicit understanding that certain speeds are slow. There's really no way that a word spotting solution will be able to correctly group that together. And you'll notice here suddenly the word speed, we've got the word buffering again, we've got data rates being low, which the large language model understands to be slow internet. So straight out the gate, we see the need to group things together is really important and count them. And with word spotting, the need to be able to define all of the words and permutations that might possibly signal those things becomes unmanageable very quickly, whereas large language models are able to do that. The next problem we need to address is speech transcription quality. If you've got a voice contact center, you'll be using a speech to text transcription system, and often they're not great quality. I mean, I'm not going to read this to you, but if you try and skim read, this is a real sentence I pulled out of a conversation. It's really hard for a person to tell what this particular transcription is referring to. And it will be very easy for a word spotting solution to home in on words like transfer and update and possibly draw the wrong conclusions. So let's look at an example of how large language models can help tackle some of these problems. We have here a transcript of a conversation of a customer who wants to cancel their service, and they want to cancel it before the next billing cycle. But they either said the word circle, but more likely the speech to text transcription detected the word circle, which you would probably not guess if you were writing a word spotting system means cycle. But notice how when the large language model is asked, what does the customer want to do? It doesn't refer to billing circles. It essentially corrects it and refers to the fact that they want to cancel their service before the next billing cycle. So again, the statistical nature of language models, understanding the context of language, has automatically corrected this transcription error up here, which gives us a robustness against the noise that we get from transcription errors. Next thing is that context really matters. So as we've seen, each step of a dialogue builds on a previous one. So the order that things happen, the context, and also the tense of the language matter. And traditional word spotting systems aren't sensitive to this. So I'm going to show you an example here. Here's the conversation. It's based on a real conversation where someone's reporting a problem. They're having trouble getting through to Mexico, and they've checked their account here, and their balance appears to be sufficient. So the lived experience of the caller is that they believe that there is a problem getting through to Mexico, and they've checked and they don't believe the problem is related to their balance. So they're essentially presenting with a technical problem here. And when we ask the large language model to summarize this, you'll see that it correctly says they're reporting a problem with their international calling service, and it correctly identifies that they've already checked their account. But with a traditional word spotting system, you may well be looking for things like account balance and speculating that this is an inquiry about balance. You may also notice that there's mention of international calling service, and you won't know what to do with it. Now let's flip this conversation around and look at almost the same conversation where someone calls in and says, I need to check my account balance because I've been trying to call my family and I'm not getting through. Now, in this case, the customer's working assumption is that the problem is to do with their account balance. They've essentially, as we can see later, correctly diagnosed that the problem is to do with their account balance. But you can see from the point of view of a traditional word spotting technology, we've got all of the same things going on here, calls not going through to Mexico, etc. The chances that a word spotting technology can tell the difference between these two conversations is extremely low. But when we took a look at what the large language model did with this, it correctly says that in this case, the underlying driver is to check the account balance, whereas in this one, the underlying problem was they were concerned with their international calling service. And you'll see it's also correctly picked up the diagnosis here that they've been blocked due to past due balance. So this is particularly exciting because it means now we can take into account context, we can take into account the order of things, and we can start drawing correct conclusions and distinctions between underlying customer drivers and solutions. Another common problem that we see in conversation is negation. This is taken from a real conversation, again, slightly obscure, but it's a real conversation. And look at the number of occurrences of negative phrases in here. It's not a problem. I wasn't given an option. I don't want to be charged, etc., etc. Again, word spotting technologies have real trouble with negation. So they can hone in on things like, the word charge and think that the conversation might be about being charged rather than not wanting to be charged, for example. So it's an extremely common problem with word spotting technology that it essentially gets the sense of things wrong and reports things the opposite way around to how they should be. Large language models do also struggle with this, but they're getting close to doing a good job on it now. So let's take a look at an example here now. We've got a conversation. I can't make a payment today and I don't want to be charged. And then the agent says, well, that's actually fine because your bill isn't due until Thursday. So we've got three sort of negations there. And then we have a straightforward negation here, which word spotting finds very, very hard. The customer says, I thought I had to pay today. And the agent says, no. Well, it's extremely hard with traditional word spotting technology to know what that no might be referring to. But large language models can do a pretty decent job of it. So when we present this conversation to a language model and we say, does the customer want to make a payment? It gets it right. It says no, the customer does not want to make a payment today. And it also correctly understands that they're trying to avoid being charged and that their bill is not due till Thursday. So again, this is exciting because whilst the language models don't always get it right, they're starting to make a decent job of negation and actually understanding these negative and positive contexts. Next, sequence really matters. In understanding, for example, compliance for a contact center conversation, it's really important that things happen in the right order. So we've got things like validation questions, making sure compliance actions happen at the right moment, checking troubleshooting steps happen in the right order, and checking, for example, that retention offers are made at the right moment and with the appropriate amount of questioning. We take a look at the conversation here. We have someone who's got a concern about their smart speaker. The next step is that they're establishing whether they're under warranty or not. Then the agent explains that they've got to do some troubleshooting before they can basically deal with it as a warranty. So they go through a number of steps. Have you tried unplugging it? Have you checked it's on the Wi-Fi? Here's how to get on the Wi-Fi. Now try and play some music. And here we go. The customer's confirmed after all of this is still not working. And now the agent can go ahead and here's the key one, schedule an appointment for a technician. Now, this is a very, very costly step, so it's very, very important that we can check that agents are following correct procedure leading up to this. So I fed this conversation into a large language model. I haven't bothered showing you the actual prompt with the conversation in because it was a bit long. So instead, you can just see this prompt at the top here, using up to 7 words for each step, list the trouble steps taken by the agent. And you can see it's done an amazing job of going through each of the steps, checking the warranty, permission to troubleshoot, unplug, check it's assisted, helping them connect, asking them, confirming that there's still a problem, confirming it's probably a hardware issue, and then here's the final step here. Now, we've still got a categorization problem. If you're going to analyze hundreds of thousands of these conversations, you've got to somehow categorize all of these steps and make sure that they're correct because they may be expressed differently. But you can see how we're making major steps forward towards being able to actually check sequence and compliance issues that have got sequential implications. Okay, finally, and we're just going to wrap up. There's a huge amount that goes unsaid in conversations, and we call this often out of band information. Now, this might be common ground that we talked about earlier, or it might be information that's specifically known about the customer. So, for example, both the customer and the agent may already know what products the customer have, so they may never actually bring it up in the conversation. Both the customer and the agent may well know whether their payments are up to date or not, whether this is a repeat contact, has there been recent communication, etc., etc. So there's a huge amount that an agent can know by looking at the online systems, and there's a huge amount a customer knows just by dint of the fact that they've got the lived experience of the account, which means there's quite a lot that might be known in the conversation, but never actually surfaces. And this can be a really big problem for conversational analytics. So let's look at an example here of how we might start to address this problem with large language models. Of course, a language model can only deal with the information it's given. So let's just work through this conversation here. We've got a customer who says that they want to order 5 iPhones and they want them delivered to a different address. The agent asks them essentially why do they want to go to a different address, because this is potentially a high-risk situation. Then we're given what essentially is a plausible explanation here. The sister they're living with their sister at the moment. And then the agent essentially has the job of saying no. So they say, we can't do this. And the customer then, as we talked about earlier, uses their social power to escalate. And the agent essentially warns them it's not going to be any different, but they can have the escalation anyway. So they get them over to the agent. Now let's look at what a large language model does with that conversation. You can see here, got the conversation presented at the top, and the question is, what's the outcome of the conversation? And the large language model says that the order can't be placed due to limitations on the account. We've got a spelling error here, but that we can't fulfill this order at the moment, but no real reason is given. Now let's imagine that we have access to the back-end status of the account, and we feed this into the large language model prompts. So now we present exactly the same prompt. We take information that's known to the backend system here, that there's a fraud flag on the account, and we add that into the prompt. And then notice now when we ask the large language model, what's the outcome of the conversation? It doesn't know, but it plausibly infers that the reason that the order was denied was due to the fraud flag on the account. So we're starting to get some hints here about how we can take out-of-band information, knowledge that we know from background, and weave it into our analytics using large language models to get more contextual interpretation of what might actually be going on in the conversation, even though that information doesn't appear in the conversation itself. Okay, so it's been quite a rapid fly through some of the issues, but we just looked at how conversations are unique with specific characteristics, and they contain a lot of unverbalized information, a lot of noisy and overlapping words and data. Contact center conversations have very specific characteristics to do with the asymmetry of relationship between the speakers. And then we looked at how conversational analytics needs to be able to categorize and count things, which is a unique requirement beyond basic language models. But they do also need to be able to extract information from variable and noisy sources, which large language models are proving to be very good at. Word spotting isn't up to the job, and large language models are showing real promise in moving these things forward. So thank you for listening. The next presentation in the series, the webinar series, will look at how large language models are changing the nature of chatbots and IVRs and how that is impacting on the contact center. Thank you very much for your time, and I look forward to answering some questions.
Thank you, David. That was excellent. Now we're going to go into a few questions that people have sent in both before the webinar and during the course, and we'll answer those now. Let me give you the first question. I was particularly interested in your observations on the asymmetry of contact center conversations. How does this change when agents make outbound calls?
That's a great question. Clearly, the roles of who initiated the conversation will flip over, and the conversation becomes driven by the fact that the agent presents the opening goal rather than the customer. But the power balance will remain the same. So the customer retains their high social power, and the agent will retain their, as we called it in the presentation, their structural power. This works out into a structure where the start of the conversation will now be dominated by the agent's need to persuade the customer to adopt their goal for the call, because essentially the agent's coming from a position of relatively low social power at that point, and they need to persuade the customer that there's an important reason that will impact their lived experience. That means they need to engage. This could be, for example, because they're going to lose service if they don't pay a bill, or it could be that they're going to get a great product. So structurally, the calls do look a lot different as a result, even though the roles remain the same.
Thank you, David. Another question. You show a lot of interesting individual LLM examples. Are there any products out there that actually use LLMs like this, or are you mostly talking about the potential that exists for new products at some point in the future?
Well, the adoption of LLMs is, as I'm sure you're all aware, moving really, really fast in the marketplace at the moment. I can't really speak for other providers. We're seeing announcements being made daily, but they're not always, they may not always be substance behind the announcements. There's a lot of providers out there who want to appear to be moving faster than they actually are. There are two main challenges to wide-scale adoption of LLMs, particularly in conversational analytics. The first is cost. To use LLMs on very large volumes of conversations is currently quite costly due to the high demands of memory and processing power. But this is changing very, very rapidly, and the barrier is reducing almost daily. The second is the need for categorization, as we discussed in the presentation. So you can deal with a very, very large number of observations from conversations in categories rather than as individual conversations. Within TalkMap, we've used generative AI since 2019 and have already dealt significantly with the issue of categorization at scale. Integration of larger foundation models are pretty straightforward for us, and we're working on finding ways to make the cost-benefit equation balance, which we think that moment's going to be coming pretty imminently.
Thank you so much, David. Another question. You mentioned the poor quality of speech-to-text transcriptions for contact center conversations. I was under the impression that speech-to-text is now extremely accurate. Can you explain this? Asked the person there. Thank you.
Okay, yeah, this is a good question. I mean, in parallel with the large language model revolution that we've had in the last couple of years, there's been a similar revolution in the accuracy of speech-to-text, particularly for telephone conversations, which are very, very challenging. In spite of this, many contact centers are using older infrastructure with speech-to-text providers that are not state-of-the-art and may not even be using the most up-to-date algorithms. This is often due to lags in capital investment cycles, and it means that the quality of speech-to-text that contact centers have access to is often a generation or even two generations behind what's currently state-of-the-art. This will catch up, and I believe the problems of transcription quality will reduce significantly over time. But right now, it's still a significant barrier, certainly in many of the larger enterprises that we engage with.
Thank you, David. Someone else asks, and I obviously can't say which company they're from, but they say they have a large team of analysts working on defining patterns for conversational analytics. Are LLMs going to make this role redundant at some point in the future?
Again, a really good question. I'm assuming the question implies that those people are working on more sort of word spotting technologies. And if they do, the short answer is yes. I think the need for those large teams of people defining patterns is going to go away. There shouldn't be a need moving forward for people compiling lists of phrases and context for your conversation analytic tools. And I'm hoping this presentation has kind of laid the foundation for why that's true. The TalkBack tool, for example, automatically identifies the calling reasons, agent actions directly from conversation transcripts and labels them automatically with no need for any human definition or intervention. There is still going to be demand for people with skills to interrogate these new generational analytic tools and identify and to some extent still quantify actionable insights. This will, I think, require less people with a higher skill set in the future. So maybe one day you'll be able to just ask the AI, what changed in my contact center this month and what should I do about it? but we're not quite there yet.
Interesting. Someone asked, David, I really enjoyed the presentation today. We've tried implementing conversational analytics at our call centre and found that it's failed to meet expectations. While I can't tell you who the provider is, any tips you have for us as we look at a new vendor for conversational analytics and some of the key things we should be thinking about in an RFI?
I hope the presentation answered that question to some extent. I'm speaking in my own personal opinion here, but the main reason for failure that we see with our own customers who are using sort of existing conversational analytics tools is just the inability to deal with the issues that we talked about in the presentation. So an over-reliance on the presence or absence of certain words in a conversation to mean something without taking into account the context. Sometimes a lack of tooling in being able to, once you discover statistics around the occurrence of certain words, being able to actually dig in and understand what those conversations look like and how they differ from other conversations that you might be working with. So I would say that the lack of delivery that we see, that our customers currently see with the current tooling, is really down to an immaturity in the language technology to be able to actually answer the questions that they need answering. And I do genuinely believe that foundation models plus other important infrastructure that goes around that. So, for example, frameworks for counting and categorizing and looking for differences and things like that. I think we need that leap forwards before conversational analytics was going to deliver the promise. And I believe it is now starting to really deliver that promise.
David, someone else asks here about utterances and what's TalkMap's ability to capture utterances and how does this really factor into conversational analytics?
I'm not entirely sure what you mean by capturing utterances, but one of the things that's quite unique to TalkMap is that we label the conversations up at the utterance level. So as you'll have seen from the presentation, you can characterize a conversation as, an utterance from an agent, then an utterance from a customer, an utterance from an agent, utterance from a customer. And certainly within our tool, we label each individual step with automatically discovered labels. And that allows you to tackle a huge amount of things. It allows you to deal with the granularity of things like the actual steps that are taken in conversation. Because you're labeling every single step rather than dealing with just conversation level stuff, it allows you to answer questions about sequence and ordering. It allows you to answer questions about what might be missing in the sequence, etc. So at the end of the day, usually when you're reporting, you're going to want to be counting things at a conversation level. It's important that the underlying tools are actually able to deal with individual steps in the conversation and categorize and label them.
Thank you so much for all the questions. And David, thank you so much for all the preparation in today's webinar, which was substantial and a totally fascinating subject. As always, to learn more about TalkMap, visit talkmap.com or email us at info@talkmap.com. We'll be sure to update everyone when we have the next webinar scheduled and ready to go. Thank you, David.
Thank you very much.